before humanity. The day Earth changed forever, we like to believe that humanity was always destined to exist. That from the very beginning of Earth's history, everything was somehow leading toward us. But science tells a far more fascinating story. Our existence was never guaranteed. It depended on countless accidents, impossible coincidences, and events so unlikely that if just one of them had unfolded differently, no human would ever have walked this planet. The story of humanity begins long before the first stone tools, before the first primates, and even before mammals ruled the earth. It begins in a world that looked completely different from anything we know today. Imagine standing on Earth nearly 70 million years ago. There are no cities, no mountains shaped by modern civilizations, no birds singing from suburban trees. Instead, endless forests stretch across warm continents filled with gigantic reptiles. Massive titanosaurs move slowly across open plains while armored ankylosaurs graze nearby. In the distance, enormous predators patrol the landscape, dominating every ecosystem they enter. For over 160 million years, dinosaurs ruled almost every corner of the planet. Contrary to popular movies, dinosaurs were not simply giant monsters constantly fighting each other. They formed incredibly complex ecosystems with specialized hunters, scavengers, herbivores, and even feathered species that closely resembled modern birds. Many were intelligent enough to hunt in coordinated groups, while others cared for their nests and protected their young. Meanwhile, mammals already existed, but they were hardly noticeable. Most were no larger than modern mice, living hidden lives beneath fallen trees or inside underground burrows. They survived by staying out of sight, feeding at night, and avoiding the attention of the gigantic reptiles above them. If someone had visited Earth during this period, almost nobody would have predicted that these tiny creatures would one day inherit the planet. Everything changed in a single geological instant. Around 66 million years ago, a massive asteroid roughly 12 kilometers across entered Earth's atmosphere at incredible speed. Its destination was what is now the Yucatan Peninsula in present-day Mexico. The impact released more energy than billions of nuclear bombs exploding simultaneously. The explosion vaporized rock, launched molten debris into space, and created shockwaves that traveled around the entire globe. Forests ignited thousands of kilometers away. Earthquakes shook continents. Tsunamis hundreds of meters high raced across ancient oceans. Yet the asteroid itself was only the beginning. The real catastrophe unfolded over the following months. Dust, ash, and sulfur particles rose high into the atmosphere, blocking sunlight around the world. Temperatures dropped dramatically. Photosynthesis nearly stopped. Plants died first. Then the animals that depended on those plants disappeared. Finally, the predators that hunted them also vanished. Within a relatively short period of geological time, nearly 75% of all known species on Earth became extinct. Every large non-avian dinosaur disappeared forever. For decades, scientists believed the asteroid alone caused the extinction. Today, however, many researchers think the story is even more complicated. Long before the asteroid struck, enormous volcanic eruptions in what is now western India had already begun reshaping Earth's climate. These eruptions, known as the Deccan Traps, released enormous amounts of carbon dioxide and sulfur gases over hundreds of thousands of years. Some scientists believe the planet was already under environmental stress before the asteroid arrived. The impact may have been the final blow that pushed fragile ecosystems beyond recovery. This remains one of the most actively debated questions in paleontology, and it reminds us of an important lesson. Earth's history is rarely shaped by a single cause. Instead, enormous changes often emerge from multiple disasters happening at exactly the wrong time. One popular myth claims that dinosaurs failed because they were poorly adapted. Nothing could be further from the truth. Dinosaurs were among the most successful groups of animals that ever lived. They survived changing climates, shifting continents, and countless evolutionary challenges for more than 160 million years. Human civilization, by comparison, has existed for only a tiny fraction of that time. Their extinction was not evidence of weakness. It was evidence that even the most successful species can disappear when the environment changes faster than evolution can respond. Once the giants vanished, Earth entered an entirely different chapter. Forests slowly recovered. New plants spread across the continents. Fresh ecological opportunities appeared everywhere. For the first time in millions of years, enormous habitats stood almost empty. This sudden availability of ecological space became one of evolution's greatest opportunities. Small mammals, once restricted to living in the shadows, began expanding into environments that had previously been impossible to occupy. Some evolved into fast runners across open plains. Others adapted to rivers and lakes. Some returned to the oceans, eventually giving rise to whales. Others developed wings and became bats. Evolution was not following a blueprint. It was experimenting. Every generation introduced tiny genetic changes. Most failed. Some survived. A very small number unlocked entirely new possibilities. Among these countless evolutionary experiments, one particular branch began moving toward a life in the trees. Dense forests offered protection from predators, abundant food, and countless opportunities for climbing. Living above the ground demanded new abilities. Hands capable of gripping branches, flexible shoulders, excellent balance. Most importantly, eyes that face forward instead of sideways. Forward-facing eyes allowed precise depth perception. This made jumping between branches far safer. What seems like an ordinary feature today would eventually become one of the foundations of human vision. Millions of years later, those same eyes would help artists paint masterpieces. Engineers build skyscrapers, surgeons perform delicate operations, and astronauts navigate spacecraft beyond Earth. One simple adaptation for climbing trees would eventually transform into something far greater than survival. But evolution never plans for the future. It simply rewards whatever works in the present. Perhaps the greatest misconception about evolution is that it always moves toward intelligence. It does not. Nature has no ultimate goal. There is no final destination. No perfect organism waiting at the end. Evolution only favors whatever increases the chances of survival in a specific environment. If circumstances had remained unchanged, intelligent humans might never have evolved at all. In another version of Earth's history, dinosaurs could still dominate the continents today while mammals remained insignificant nocturnal creatures hiding beneath their feet. That possibility is both unsettling and extraordinary. Our existence may depend on one cosmic collision that happened 66 million years ago. Without that single event, there would be no civilizations, no languages, no science, no history, no one asking where humanity came from. And yet, despite surviving the greatest extinction since the age of dinosaurs, mammals were still very far from becoming human. The most remarkable chapter of our story was only just beginning. The first primates. Life above the ground when the dinosaurs disappeared. Earth did not instantly become a paradise for mammals. The world remained dangerous. Massive flightless birds hunted across open landscapes. Giant crocodile relatives still ruled many rivers. Predatory mammals were beginning to evolve, competing for every available source of food. Survival remained a daily struggle. But hidden above the forest floor, another evolutionary experiment was quietly unfolding. The forests that spread across Africa, Europe, Asia, and North America after the extinction became some of the richest ecosystems the planet had ever seen. Towering trees formed enormous green canopies stretching for hundreds of kilometers. For small mammals, these forests offered something priceless: safety. Most predators hunted on the ground. Few could easily navigate the tangled maze of branches high above. Around 60 to 55 million years ago, a new group of mammals began adapting to this three-dimensional world. These were the earliest primates. Unlike many other mammals, they did not rely on speed or physical strength. Instead, survival depended on precision. Every jump between branches carried enormous risk. One mistake could mean falling several meters onto the forest floor, where hungry predators waited below. Natural selection rewarded individuals capable of making more accurate decisions. Over millions of years, remarkable changes appeared. Their fingers became longer and more flexible. Sharp claws gradually disappeared, replaced by flat nails that improved delicate grip. Sensitive fingertips allowed them to feel bark, fruit, and tiny insects with incredible accuracy. Perhaps the greatest transformation occurred inside their eyes. Most mammals have eyes positioned on the sides of their heads, giving them a wide field of view to detect approaching predators. Early primates evolved something entirely different. Their eyes slowly moved toward the front of the face. This reduced peripheral vision but created overlapping visual fields. For the first time, the brain could accurately judge depth and distance. Today, every time you catch a ball, drive a car, or pour water into a glass without spilling it, you're relying on an adaptation that first evolved millions of years ago among ancient forest branches. But the hands changed just as dramatically. One finger became especially important: the thumb. As the thumb became increasingly opposable, primates could grip objects with remarkable precision. This may seem insignificant, Yet nearly every tool ever created by humans, from stone axes to smartphones, depends on this single anatomical innovation. Evolution rarely creates something entirely new. Instead, it transforms existing structures into tools for completely different purposes. The thumb first evolved for climbing. Millions of years later, it would help humans build civilizations. Another misconception often repeated is that humans evolved because we developed bigger brains first. Science shows the opposite. Long before brain size increased dramatically, evolution had already been improving vision, hand coordination, balance, and movement. Intelligence was not the beginning of the journey. It was one of its final outcomes. The forests demanded constant problem solving. Which branch could support your weight? Which fruits were safe to eat? Where were poisonous snakes hiding? Which routes allowed escape from predators? Every decision carried consequences. Those capable of processing information more efficiently survived slightly more often. Tiny advantages accumulated over millions of generations. The brain slowly became more sophisticated, but intelligence alone was not enough. Social behavior became equally important. Modern studies of chimpanzees, bonobos, orangutans, and other primates reveal something remarkable. The most successful individuals are not always the strongest. Often, they are the ones with the strongest social relationships. They cooperate, share food, protect one another, remember friendships, recognize rivals, even reconcile after conflicts. Some primates comfort injured companions. Others adopt orphan infants. Many display emotions once believed to belong exclusively to humans. This discovery has transformed how scientists view our own origins. Compassion may be far older than civilization itself. One fascinating example comes from modern capuchin monkeys. Experiments have shown that when one monkey receives a poorer reward than another for performing the same task, it often protests or refuses to continue. Although this is not human justice, it suggests that the roots of fairness evolved long before modern society. Another surprising fact concerns communication. Many people believe language suddenly appeared with Homo sapiens. In reality, communication has much deeper evolutionary roots. Different monkey species use distinct alarm calls for different predators. Some calls warn about snakes. Others specifically signal birds of prey. Still others alert the group to large mammals approaching through vegetation. Each sound triggers a different escape strategy. This demonstrates that symbolic communication existed millions of years before spoken language. Perhaps our ancestors didn't invent communication. They expanded it. Another myth suggests evolution always favors the smartest individuals. Nature isn't looking for intelligence. It rewards whatever increases survival. Octopuses evolved remarkable intelligence despite having no backbone. Crows solve complex puzzles. Dolphins recognize themselves in mirrors. Human intelligence represents only one evolutionary solution among many. It is not the only path nature has explored. While life flourished in the forests, Earth's climate was beginning to change once again. Tectonic plates continued drifting. Mountain ranges slowly rose. Ocean currents shifted. These geological processes gradually transformed global temperatures and rainfall patterns. The dense tropical forests that had protected early primates for millions of years would not last forever. Across parts of Africa, patches of woodland slowly began giving way to more open environments. At first, these changes seemed insignificant. A few clearings, longer dry seasons, scattered grasslands replacing ancient trees. But evolution often begins with tiny environmental shifts that eventually reshape the entire planet. The descendants of those tree-dwelling primates would soon face a challenge, unlike anything their ancestors had ever encountered. For millions of years, the trees had been their greatest ally. Now, many of those trees were disappearing. Some species vanished. Others retreated deeper into surviving forests. But one small population would attempt something extraordinary. Instead of remaining in the trees, they stepped onto the open ground. That decision would begin one of the most important chapters in the history of life. The path toward becoming human had finally begun, walking into the unknown. The first steps toward humanity for millions of years. Our ancestors lived almost entirely in the trees. The forest provided food, shelter, and protection from countless predators. Every branch was a pathway. Every canopy served as a fortress above the dangers below. Then the world began to change. Around 10 to 7 million years ago, global temperatures slowly declined. Africa's climate became drier, and vast tropical forests gradually fragmented into scattered woodlands, separated by expanding grasslands. This transformation did not happen overnight. It unfolded over millions of years. But for the animals living there, every generation faced a slightly different world than the one before. Food became less predictable. Trees stood farther apart. Traveling from one forest to another often required crossing open ground filled with predators. Lions had not yet evolved in their modern form, but giant saber-toothed cats, enormous hyenas, crocodiles, and powerful birds of prey dominated these landscapes. The safest home on Earth was slowly disappearing. Many primate species simply retreated into the remaining forests. Their descendants eventually became today's chimpanzees, gorillas, and other great apes. But one small population took a different path. Instead of avoiding the open landscape, they adapted to it. This decision would forever change the course of evolution. Among the earliest known members of our evolutionary family were species such as Sahelanthropus, discovered in Chad, and Ornithogenensis, found in Kenya. These ancient relatives lived between 7 and 6 million years ago. Scientists still debate exactly where they belong on the human family tree. However, their fossils suggest something extraordinary. Even this early, some individuals may have spent part of their lives walking upright. Contrary to popular belief, humans did not suddenly stand up one day. Bipedalism evolved gradually over millions of years. At first, our ancestors probably walked on two legs only when necessary. They still climbed trees regularly and slept among the branches. Their bodies were caught between two worlds, neither fully adapted to life in trees, nor fully adapted to life on the ground. One of the most important discoveries came from Ethiopia. Around 4.4 million years ago lived a species called Ardipithecus ramidus. Nicknamed Ardi, this ancient hominin challenged decades of scientific assumptions. Unlike modern chimpanzees, Ardi's hands and feet reveal that our last common ancestor was probably not a knuckle-walking ape. Instead, both humans and chimpanzees evolved in different directions from a much older ancestor. This completely changed how scientists reconstruct our origins. For decades, illustrations often showed human evolution beginning with something that looked almost exactly like a chimpanzee. Modern evidence paints a far more complex picture. Neither humans evolved from chimpanzees, nor chimpanzees from humans. We simply share a distant common ancestor that lived millions of years ago. Another widespread myth claims that standing upright happened because our ancestors wanted to free their hands for tools, while freeing the hands eventually became important. Evidence suggests that bipedalism appeared long before systematic tool use. So why did evolution favor walking on two legs? Scientists continue debating this question. Several explanations appear likely. Walking upright reduced the amount of direct sunlight hitting the body during the hottest hours of the day. This helped regulate body temperature across open savannas. Standing higher also allowed individuals to see predators above tall grass before it was too late. Walking efficiently over long distances required less energy than moving on all fours across open terrain. And carrying food or even infants became much easier with free hands. No single explanation fully solves the mystery. Most researchers believe several advantages work together over millions of years. Evolution rarely changes one feature for only one reason. As our ancestors spent more time on the ground, their skeletons slowly transformed. The spine developed gentle curves to support an upright posture. The pelvis became shorter and wider. Leg bones strengthened. Feet gradually lost the ability to grasp branches as efficiently. The big toe aligned with the others, creating a stable platform for walking. These changes occurred incredibly slowly. No individual noticed evolution happening. Parents looked almost identical to their children. Generation after generation, tiny differences accumulated until entirely new species emerged. Then, around 3.9 million years ago, another remarkable species appeared, Australopithecus afarensis. Its most famous representative would later become known simply as Lucy. Discovered in Ethiopia in 1974, Lucy remains one of the most iconic fossils ever found. Standing just over 1 meter tall, she possessed a brain only slightly larger than that of a modern chimpanzee. Yet her skeleton revealed unmistakable evidence of habitual upright walking. Perhaps the most astonishing discovery came only a few years later. At Laetoli in modern-day Tanzania, scientists uncovered fossilized footprints preserved in ancient volcanic ash. These footprints were approximately 3.6 million years old. They showed at least 2 or perhaps 3 individuals walking upright across damped volcanic ground, step by step, exactly like humans do today. The footprints tell a story that bones alone cannot. One individual appears to have slowed down, possibly waiting for another. Some researchers even suggest they were walking together as a small group. Although we can never know exactly what happened that day, those footprints preserve a frozen moment in deep time, a family, friends, or simply travelers crossing an ancient landscape. Millions of years later, their journey still speaks to us. Another common misconception is that Lucy was our direct ancestor. The truth is more complicated. Evolution resembles a branching tree, not a ladder. Many human relatives lived at the same time. Some left descendants, others vanished forever. Lucy may represent one branch that contributed to our lineage, or she may simply be one of many close relatives sharing similar adaptations. Nature constantly experimented with different solutions. Some species developed stronger jaws for chewing tough plants, others became larger. Some specialized in forest life, others adapted to increasingly open grasslands. Most eventually disappeared. Only one branch would survive long enough to become us. But survival required more than walking upright. Open landscapes demanded something else: cooperation. A single individual crossing the African savanna had little chance against powerful predators. Groups stood a much better chance, sharing food, watching for danger, protecting children, learning from one another. These behaviors slowly became just as important as physical evolution itself. The greatest strength of our ancestors was never speed, it was never sharp teeth, it was never enormous muscles. It was their growing ability to solve problems together. Without realizing it, these early hominins were laying the foundation for something entirely new. Not just a different body, but a different way of surviving. Soon, another revolutionary step would transform evolution forever. For the first time in Earth's history, one species would begin shaping the world with objects it deliberately created. The age of tools was about to begin.